Hi, everybody. Okay, we're going to start this talk right now. The title of the talk will be Docker, but Docker for a specific kind of people. We're going to be that people. It's going to be Docker for people in a hurry. Why are we people in a hurry? Because there are a lot of different levels of experience here. Some have heard Docker, some may have not. So we're going to cover a little bit of everything. So how did Docker start? Well, Docker started as a company called .cloud. It originally was released as an open source project they had in mind. But within a year of release, in 2013, it started attracting more attention from the open source community. Everybody was hearing about this interesting project, and more contributors started pitching in what could be done with it. Eventually, this open source project became so big that .cloud changed the company around it, and eventually .cloud closed. They were a hosting company, but instead, they opened up a new company called Docker Inc. This is nice and all, but weren't we people in a hurry? The great thing about people in a hurry is that we're always on the move. We are making important decisions about how to best invest our time. I'm wondering if the things that we are investing in are worth it, are truly important. So, is Docker really important? Why should we learn Docker? Well, Docker is easy. What is easy? That is achievable without a great effort. I'm taking this out of the dictionary. It's easy to learn, use, and master. In the most recent Stack Overflow survey review for developers, 73.6% of the developers that took the survey has expressed interest in continuing working with Docker. Docker also was scored as the #1 most wanted technology to work with. It's easy to learn, to use, and master, but also it makes stuff easier. What do they do? We're gonna see that in a minute. Docker is also relevant. What is relevant? That is connected or appropriate to what is being done or considered. We're talking about our environment as a developers. It's relevant because it's not a question about whether I'll use Docker ever, but actually when will I start using Docker? According to Docker Captain Brett Fisher, Docker is the next once in a decade shift in infrastructure. And we've had some of those for some decades now. In the 90s, everything was being done in mainframe infrastructure, but then we migrated to a distributed PC infrastructure. It was the rise of Mac, of Windows, DOS, if you remember. At the turn of the century, we shifted toward virtualization. We had these giant servers and data centers that were not being really used. We started creating lots of OSs inside a single piece of hardware to improve utilization of our resources. It came with VMware Hyper-V. In 2007, 2008, AWS first released our first idea of how it would be to use the cloud, how we favor easy, cheap, disposable compute power that can be spin up and shut down in an instant. We're all using the cloud somehow these days. And finally, we are in the middle of a new shift in infrastructure from host applications to containers. More on that in a moment, as the next object of compute. Here we're talking about every software that can be run inside a containerized environment. Here we're talking about not big monolith, but actually small pieces of software. That's where microservice, serverless, and Docker play here. It's relevant because we stop thinking about whether it's PC, whether it's virtual, whether it's cloud. It's just there. It's the new default. It's not relevant. It's relevant because when we will start using Docker. And finally, it's because it's marketable. According to Sing by Indeed data, since 2014, job postings for Docker have asking for Docker as a hard skill have increased in 9,538%. This is from 2014. The same data can be shown each year from March 2018 to March 2019. This trend has continued. The job openings have increased in a 49.24% since that date. Since we're people in a hurry, we're investing in learning a new tool. We definitely expect it that it pays off. And Docker does. As more companies take part of this trend, the more and better job posting we can find it. And since we are considering, okay, what decisions are important for us, money is one of them. So what's Docker? Because we know that Docker is important. According to that it's easy, it's relevant, it's marketable. But what does it do? Well, Docker is a containerization platform that packages your application and all its dependencies together in the form of a container to ensure that it works seamlessly in any environment. We don't know yet what a container is, but what can we get from this? We understand that a container is a package where we store our application and dependencies. What kind of dependencies? What are dependencies? Well, it's any library, any module, any file or OS that we need so that our applications run. Everything our application needs must be packaged inside a container. But it says also that it works in any environment. How do they accomplish this? Well, let's check out what else is a container so we can get a better idea. Containers are a standardized unit of software that allows developers to isolate their applications from its environment. And that's how they do it. Isolation from the environment that the container is running on top of. They still run in your computer. They still use your resources, but they do it on top of a level of abstraction called Docker, which is also called the Docker engine. And that's the promise that Docker makes to you as a developer. As long as the Docker engine runs on your platform, the containers will run seamlessly on top of Docker. That's why they run in any environment, but isolated from it. And how do we start learning Docker? Well, we first need a Docker Hub account that you can get at https://hub.docker.com. You sign up, create an account. I have mine right here. We're going. And once we log in, we are inside Docker Hub. Now that we have our Docker Hub account, we can move on. And what else do we need? Well, we need a computer. But depending on the computer that we have, we might have to think a little bit how we're going to install it, because Docker is not just a container runtime. It matters how you install it. It matters the edition that you're using. There are community edition and enterprise edition. We're going to focus on community one. And we also can choose between the stable releases and the edge releases. For this talk, we're going to use stable, which has the most secure features and the latest secure release, stable release that Docker provides. Okay, if you are using Linux, well, we're going to use Docker for Linux that runs using the Linux kernel. We can find how to install it in docs.docker.com/engine/install. It's a little bit different. I think I had it here. Yeah, we have it here. It depends on your distribution, whether it's CentOS, Debian, Fedora, Raspbian, Ubuntu. There are other distributions as well, but you can download it from here. If you're using instead a Mac or a Windows user, well, we have two options. We have the Docker Desktop, which is the new product that Docker is providing for us. which already handles lots of virtualization on top of our operating system. These are a solution for the most modern versions of both Windows and Docker. But we also have another option, which is Docker Toolbox. Now, this is considered by many a legacy version of Docker, which should be used with earlier operating systems. But we also have a slight advantage of Docker Toolbox. That's why it imports while we're using it. And it's in the inclusion of the Docker machine tooling, which allows us to create multiple and provision multiple Docker engines. But a little bit on that later. We're in a hurry after all. If you are not using Linux, Mac OS, or Windows, or you don't want to run the Docker engine in your computer because it might not be the solution for you, we have the cloud. And since we are using the cloud, well, we have two options here. Two main ones at least. We have Play with Docker, which is a nice tool that Docker provides for us, which creates a Docker environment in the cloud for us to use. It's a nice tool. It connects directly to your Docker Hub account, and that's what we're going to use in this talk today. It's important to note that you can spin up a lot of Docker engines in the same session, but it only lasts 4 hours, which is more than what we'll need today. Also in the cloud, as a production tool, we can also find Docker for AWS, Azure, Google, and other Google Cloud services. If you want to follow up, you can go here. We're gonna go to play-with-docker.com. Once you're there, it's gonna pop up this interface. We're gonna press start. We have to log in first, but where it will take us is here. We're gonna start a new session. This spins up a new Docker engine, and this is what we're gonna use for this talk. More on that. Oops. Okay, now that we have officially our Docker engine running, we can start checking out what we can do with it. And the most simple example that we can have is, okay, let's start with the web server. We're gonna enter in our new instance and say, okay, I want to run a container that is going to have an nginx. So we start with the syntax, docker container run nginx. We're gonna press start. There's going to be some messages in the console, and we have our nginx server running. That's it. Yes, that's the entire use of it. You can pull software and build it directly into your computer. We're gonna, but how do we test it? Okay, I just shut down this container. We're gonna test it by allowing us to access it. And how do we access the Docker container? Well, we have to specify first that we require it that it publishes a specific port. Nginx listens to port 80. So we're gonna go again, Docker container run, publish. We're gonna say, okay, we're gonna listen to the port 80 so that it maps the port inside the container. And here is a little difference that we have to start learning on Docker. One thing is the container port, which is where are they listening to? That's the number on the right. The number on the left is the host port, which says which is the port that our host machine is listening to. This can be mapped to any port on the right, but we can only have one container being listened to on the left, which is the host, because that's the limitations that the Linux kernel gives us. It's a thing of IP addressing, not about Docker. Once we have that, we're gonna say, okay, let's listen to Nginx once again. And the nice thing about Play with Docker is that it tells us, okay, we're listening now, but we have a publish port up here. So we're gonna open this, and it's gonna take us to an Nginx server. That's great. We have a web server running right now. But if you notice on Play with Docker, how do we take this away? Here it goes. We have to keep in session so that it lives. We are right now blocked. If I Control C out of it, let's try again. We're no longer there. So how do we keep the sediment? How do we make independent our shell session from it? We're gonna go with our command again and specify we want it to run on detached mode. Once we have that, okay, we get a Docker container ID, which allows us to know, okay, this container is running. And let's see if our container is back again. It is. But how do we know the state of our container? Well, we can ask the Docker engine about it with another command called docker container ls. And it's gonna tell us about all the containers that are currently running, which is our Nginx server. And we can see that, yes, the ID is similar than the one we have down here, but it also gave it a name, which I didn't give it, which is Salesmeyer. Well, Docker Engine has this particular feature to quickly identify as a human what are the containers running. Is going to provide it a name that is going to be unique to the Docker Engine. And that way we can specify an action that we take on the container, whether by its ID or its name. Let's say we want it to be stop. We can say Docker container stop. And we can specify both by the ID or by the name. Now we can see that we no longer have a publish port, which means that if I reload my browser, it's gonna say that the web server is no more. Thing is that we still have some cleanup to do. If we do docker container ls -all, we can say that these containers are still being in some way kept inside our Docker engine that we can start it again. But if we're gonna no longer use it, we can always remove them. That command is docker container rm instead, and it's going to accept the name of our Docker containers. And that's it. Okay, now that we know how to make a Docker container run, we might want to check some more stuff. Like, what if we don't want a specific feature that already comes with the image that we are using? And here, listen up, I've said image. We don't know what those are yet. Well, I'm gonna tell you right now. When we run a Docker container, in our previous example, we say, okay, we want an Nginx container, but how does it know how to build it? Well, it has an image. It has an image published in Docker Hub. What is this? Well, we're going to check right now. An image is basically your app binaries, dependencies, and metadata about the image data and how to run the image. The official definition is that an image is an ordered collection of root file systems. changes and the corresponding execution parameters for use with a container runtime. This sounds like a convoluted definition, so we're gonna go with its application binaries and dependencies. And how do we run it? What's not an image is that it's a complete OS. There's no kernel, there's no modules, there's no drivers. The thing is that the image only provides what your application tells it needs, nothing more. Instead, the host machine provides the kernel. That's the main difference between a container and a virtual machine. We're not creating a new OS. We're already using the resources that the Docker engine and the host OS is providing us. But where do images come from? Docker Hub is the answer. Docker Hub is a hosted repository service provided by Docker for finding and sharing container images from multiple sources, be it from the community, be it from open source or enterprises that provide their services. It also comes with Docker Hub is also the world's leading service for finding and sharing container images with your team and the Docker community. It's like GitHub, but for Docker images. Metadata is defined inside of the image Docker file and how to build, and tells us how to build the image. It provides a set of instructions that guide us in the steps that we require it for it to build. It's composed of multiple layers, being the result of each build step required to run. And you can create or upload your own custom image to Docker Hub by running your own Docker file. Now, what's a Docker file? Well, it's a set of instructions to tell you this is how you build an image that creates a container. So now that we have an idea of what an image is, we can exit here and try something new. Let's say that we want to create a new image for our particular custom need nginx. So we're gonna create a new one. And this is how you do it. We're gonna create a custom nginx directory here. And we're going to create a new file that is going to be called Docker file. Okay, what are we going to say to this Docker file? Well, first we need to know where do we start. What is the image that we're going to use as a base? Because as I told you previously, it's a stack of layers. So we're going to specify here that it's going to require the latest nginx image. After that, how do we change the content of an image? Well, we have to see the documentation, and that's located in Docker Hub. So if I look for nginx and see the documentation, okay, it's going to tell us what do we need to change to configure our service. And it tells us that any static assets that we need, we're going to have to use this path. So we're going to give it a command that is going to set our working directory to user/share/ng/html. But we don't have anything to override this. So let's create a new file called index.html. Here we can set type HTML. We can tell it, okay, it's going to have a title saying the name of our talk, Docker for people in a hurry. It's not that easy when it doesn't have autocomplete. And we can tell it, okay, let's override it with hello to our custom Nginx server. And that's it. Now, how do we take this file to and place it inside our container? We're going to use one of the different statements from Dockerfile that is called copy. And we're going to tell it to copy the index.html file from our host and place it inside our container. Since we are right now on this particular working directory, it's going to place it inside that directory. And let's see what happens. We have custom images. Okay, let's tell it. How do we create a new image? Well, we no longer use Docker container, but image. And we're going to tell it, okay, build us a new image with, and we're going to tag it. We're going to give it a name that is custom Nginx. And we're going to use the dot to say, okay, it's in our current directory. What this will do is first download the Nginx image. After that, once it has all the layers that it needs to build in my machine, it's going to set the working directory to the one that I specify here. Afterwards, it's going to copy the HTML. And now we have our new image ready. Now we have to create a new container to run it on. So we're going to specify Docker container run. We're going to give it a name this time, which is Nginx. We're going to say that we want to listen to on port 80. And, oops, we're going to say is our custom Nginx image. And now our server is running. Let's see if it worked. Hello to our custom Nginx server. Now we have a custom image that we can use for our personal projects. Sometimes we're creating a Node application, a Ruby application inside for our personal project. And this is a way to do it, to publish it into Docker Hub so that you can later download it from any place on the world that is running Docker. Now that we have this, let's kick it up a notch. Here it is. Now that we know how to run a custom image, let's see if we can create a more real life scenario usage. We're going to create a database. So let's say if we create a Postgres database, okay, Docker container run. We're going to name it Postgres. And run it here. It's going to take a moment now. You will be downloading it as well from Docker Hub. Wait, what am I doing this here? We're using Docker Playground. I forgot. Now, according to this, we have right now an error. So what happened? Well, in this time, the error is telling us that we have to specify some environment variables. We could have also checked the documentation for it, but we're going to listen to it. We're going to tell it that go to the Postgres, and this actually is the best place that you can find documentation on how to run specific behaviors on your containers. Okay, it's telling us that we require that the Postgres password is set. So how do we set it? We're gonna give it an authentication, an environment variable that with Postgres host of method to trust. So let's try this again. This is a new flag that is called --f. We're gonna set Postgres host of method equals to trust. That means that any connection that is going to be sent to Postgres is going to be correct. We're gonna run it in the test mode. Oh, apparently I forgot that we have another container running right now. And that's what I told, actually this is what I told you a moment ago. Any container that you stop is going to keep living here. And since we have already given the name Postgres to it, we have to first remove it. We run this again. And now we have our database running. Let's see the logs that we have here, which we can run with Docker container logs and specifying the name of our container. We can see that everything has been set up. We can see the initialization, the user, the databases that is being created. And let's say that we now want to stop our database. We can do this with Docker container stop, Postgres. We're going to delete it. But this is, oops, sorry. But this is a weird behavior for a database. We usually expect that if we want to instantiate again, let's see if we have maintained our data. So we're gonna run it again. Docker container run, everything set. And let's see again the logs that we have. We can see that it's starting up again. It had to recreate our user, our databases. So how do we persist data here? Well, the topic of persistence is different in containers than in virtual machines, and we're gonna touch this right now. Oops. Here it is. Well, persistence is images are composing of immutable layers created by every build step in its Docker file. That's what the Docker documentation tells us. But Docker is, again, the containers are given an additional writable layer on top of the stack that allows changes. That is a good thing because we're not increasing the container size of our images. It's just changes that occur on top of the non-writable layers that the image already provided us. But the thing is that this layer is ephemeral. Any changes that we create while the container is running will go away once the container is removed. Then at the time that we run it, will not be there. The thing is that we have a way to persist changes, which is volumes. But what are volumes? Well, volumes are the preferred mechanism for persisting data generated by unused Docker containers. It is the better choice that Docker provides us, which doesn't increase the container size using it. And the thing is that it lives outside the life cycle of a given container. But what does this mean? Is that even if your container is removed, the data will be stored in a special directory outside of the container. And the next time that the volume is called upon, it will restore the data and apply it on top of the new container. We're going to see how we can do this with our Docker Postgres. And for that, we're gonna go again to our documentation. Well, here in the documentation, we know that we have an optional variable that allows us to define our volume, which is in this syntax. The Docker CLI tells us that we can apply a volume that will store the data, that it will mount the data from outside the container into the container. Well, we have to specify first where do we want it to mount. So we're gonna pick Bartley Postgres data, which is a hook that this image already provides us. So let's try it again. And we're gonna give it a name. We're gonna create a name volume that could be anything. We're gonna give it PG data and say it, okay, anything that is going to be stored in this name volume will be mapped into this directory inside a container. Oops. We have to, once again, stop the Postgres that we have already running. So, and now we're gonna give it a new flag here that is going to help us with this --rm. This tells the container that every time that the container is stopped, it's going to be removed from Docker automatically, and it's going to be helpful for us. We once again run, and now let's check once again our logs. We can see that once again it restarted the Postgres server. It recreated the user, the database. Now let's stop our Postgres. And recreate it once again. If we check once again the Docker logs from this new container, Docker container logs for Postgres, we can see that we have almost no logs. It's just a few lines. The thing is that all that the previous container had to do to instantiate our database, our users, was not needed here because it was persistent. We no longer needed to recreate anything from scratch. We already have data here. We can see our volumes with Docker volume s. If we can see, we have our name volume here. And if we inspect our current running container, we can see that we have a volume here, which is telling map everything that is going to be set in this directory to our volume. So now we have reached persistence. How else can we prove this? Well, isolated platforms work great in Docker, but most platforms, most software that we come across every day is not a single instance of anything. It's actually a connection of services. So how do we try this? How do we connect different containers between them? Well, we're gonna do this. We're gonna first stop our Postgres, which will be deleted because of the --rm flag. And now let's think of an integration. We could create a Drupal admin. I'm gonna go here to ask, how do we create a Drupal container? It's always a key to check the documentation. Okay, we are here in Drupal and it's telling us that we're actually going to need a connection to Postgres. So this is an example that we can take to know, okay, with different services from different Docker containers can be run together. Let's check it out. So we first gonna recreate this, our Postgres, and we're gonna give it a password so that we have a secure connection between our different services. I'm gonna set it password. I'm gonna tell it it's going to be my secret password. There's actually has to be someone with this password in mind. We're gonna specify a version of Postgres. Run it once again. You can see that we previously had the latest version of Postgres, and now it had to pull again the different layers that compose this particular version. Now we're going to create our Drupal container. We're going to tell it that we want to access it from port 8080. It's going to map it to 80, which is the port that Drupal is listening to. We're going to say that let's call this Drupal. And let's see how we can persist data in Drupal. Here we have the volumes. It's telling us that we have to look into var www HTML modules, profiles, sites, and themes. The good thing is that we can create actually multiple of these volumes with the same syntax. We have to type it lots of times. So we're gonna cut and paste some of them. HTML and modules. I'm gonna give it a try. I'm going to set it to Drupal on the version 8.8.2. The reason why I have this version, well, no biggie, just it's the one that I made this demo with, and we're gonna make it run. Oh yes, we're missing the detach mode, otherwise we're gonna get stuck here. And once we have this complete, we're gonna have our Drupal container that is going to be listening to on 8080 port, and it's going to publish our port here. Now, if we want to configure our Drupal page, we can go continue, and we're gonna set up the database configuration. Well, the database name is Postgres. User in Postgres, and our database password was, which was it? Yes, my secret password. And it's going to be, we're going to try this, and we're going to get an error. But what's happening here? Well, the thing is that the Drupal assumes that we're running our host in localhost. Thing is that our database has a different IP. We can check here. If we see our running containers, yes, we know that Postgres has a specific IP inside a Docker engine, but we don't know it. We could inspect inside of it to know where to point it, but the thing about containers is that they are disposable. We can we can remove it, we can stop it, we can restart it, and every time we're gonna get a different value. And that's not really scalable. We can always be checking where it's going to be published. So the thing is, how do we know what value to give Drupal here so that it connects to our database? We're gonna be using networks. And what is network? Well, if we go here, okay, that's out. Well, Docker containers, as I told you before, work great in isolation, but most applications are composed of multiple services. We know that, but how will we connect them? Well, networks allow containers to talk with each other. It's the reason why Docker containers and services are so powerful. Is that you can connect them together or connect them even to non-Docker workloads. Docker containers and services don't even have to be aware that they are deployed on Docker or whether their peers are also Docker workloads or not. Whether your Docker hosts run Linux, Windows, or anything like them, you can use Docker to manage them in a platform agnostic way. They allow also to define boundaries between services as a measure of security. Think of it as different spaces that only certain services can talk with each other. That way you reduce the risk of someone entering a container and doing stuff they're not supposed to do. Another benefit that we get from networks is that they help the scalability of services through DNS. And we're gonna check how to do that right now. Well, we're gonna stop both our containers, Postgres and Drupal. And now we're gonna create a new network. This Docker allows us to create networks to group services together and allow communication between them. So we're gonna go Docker network create. We're gonna say, okay, it's going to have a driver. This is the default one that is going to be bridge. This every time actually that you create a new container on Docker, it's going to give you the default network. The thing is that DNS discoverability is not set in our default network. So we're gonna create a new one. It's going to be, for lack of my imagination, it's going to be my network. Network we created, we have to recreate our services. So how do we tell them? Okay, place them in this container. We're gonna set network, my network. And if we inspect inside our Postgres container, is going to say, okay, it's inside my network. Now we're gonna do the same with Drupal. Tell it, okay, run network, my network. Oh, I didn't place dash. All right, okay. There it goes. And it's going to be published once again on our publish ports. We're gonna say save continue. And now we're here again, we're gonna set Postgres. Postgres again, no, it's not capitalized. Thank you, Safari. My secret password. And we're gonna go to advanced options. We're gonna tell it the name host of our database. But what was it again? Well, as I told you, DNS discoverability allows that while we are in a custom network, our host name will actually be the name of our container. So in this case, it's Drupal. No, wait. For our database, it's going to be Postgres. Just as a tip, the name allows you to know, okay, what services you are creating, but it doesn't have to be the same as the image. It's just how I'm doing it right now. So we're going to set host name. It's going to be Postgres. We haven't changed the port, and save and continue. And now Drupal has connected with our Postgres container. And here we can see how different containers, different services can interact between each other. This is great, but if you notice, this got a little tedious. And see, it gives us a lot of freedom to actually code this, but it can get tired really easily. So how do we create services in an easier way? Well, Docker gave us a tool a few years ago that tackles exactly this problem, and it's called Docker Compose. Docker Compose is actually a tool that is given so that we can define in a declarative way a multi-container Docker application. With Compose, you can use a YAML file to configure an application services and set up networking between them. This declarative approach will also allow you to create and start all the services from your configuration. You can install it from docs.docker.com compose install. And if we go here, we open this file, it's going to tell us, okay, we have a Linux right now. So what are the steps to installing it on Linux? Well, I have to run this command. Here we're in Docker Playground. Let's remove all this. Docker container stuff once again. Postgres and Drupal was it? Yes. And we're going to install Docker Compose. What else were they telling us? Oh yeah, we have to apply this. Apply executable permission for binary. Okay, how do we create a Docker Compose file? Well, first we have to write one. And let's do it here. Let's create a new directory. It's going to be my Drupal service. Go inside it. We're going to create a Docker Compose file. Docker Compose dot, and we're going to open it inside Visual Studio. Okay, we have a Docker Compose file here. We have to first start with giving it a version. For right now, we're doing stuff in development, so we're gonna need only version 2. This allows Docker Engine to Docker Compose CLI to know what features can it provide to us. So we're gonna specify this, and we have here we can specify everything that was needed for to run our services. So we have to start here first, services. So which were they? Well, first we had our database, which was here. Okay, the name was Postgres. So we're gonna name our service Postgres. Now we can specify data about it. We know that the image was Postgres 12.1. What else do we know about this? Well, we can set environment variables, which were our password. So we're gonna set Postgres password. It's going to be, once again, my secret password. And we want to persist stuff. So we're going to create a column. We're gonna leave this for a moment, And we're going to create also Drupal. We're going to set it an image. We're going to tell it it's going to be, oops, it's going to be Drupal version, which was it? 8.2, 8.8.2. Now we can create volumes. We had the modules volume that is going to be Drupal modules, and you can see that we are using the exact same syntax we were using in the CLI. It's going to be var dot HTML modules. Here we can say up here it's going to be PG data. Oops. Arlet, PostgreSQL data. And we are almost done. What other thing that we have to specify? Well, it's going to be our volumes. And since they are just name volumes, we go PG data, set it here, and Drupal modules. Once we have this, we can copy paste this. We're gonna copy and drag it here to our Docker playground. So now that we have, let's check that we have actually Docker Compose installed. I didn't check that as well. So I'm guessing Docker Compose version. Oh, it wasn't installed. Let me restart this. Here it is. I'm gonna delete this instance and create a new one, just in case. And that's sudo, no udo. Let's check once again. Do we have it here? Yes, here it is. We can see that if we go to Docker Compose or Docker Compose --help, you can get additional information about how to use this. So first we have to create a Docker Compose file. So vim Docker Compose file dot YAML. I'm gonna copy this and paste it here. Oops. Oh, how do we? Yes. Vim. Well, now that we have this, let's see. Yes, we have our Docker Compose file here. It's going to go Docker Compose. It's going to start. It's invalid. Oh, mistype. I'm gonna edit this environment. I'm hoping that's the last typo mistake. I'm gonna write it once again, but we're gonna run it in detach mode so that we can actually see what we're doing. And see, right now, Docker Compose is going to create first our network. It's going to create a specific project network. After that, it creates our volumes, both PG data and Drupal modules. Once we have that, it's going to go, once again, it's going to go for the services. Once it's created, it has pulled the images, and our containers are now running. One thing that I think that I missed is actually publishing the ports. Yay! Yep, I did. So we have to specify ports here. We're going to listen to port 80. Ports. we're going to listen to port 8080, and inside the container is going to be 80. So now we can run this again. You see, since Docker Compose noticed that I didn't change anything in Postgres, it left it alone, but recreated my Drupal container with the information I just gave it. So let's see. We're going to connect here and see that with one simple command, we have once again recreated the same thing that took us several commands to create a moment ago. So I'm going to see if everything is going as it should. It didn't. Password. What name did I give it? Okay, I'm going to correct this Docker Compose file. That's down. Secret password, pdata. Oh yes, here it is. I'm gonna pass this file here, and where is it? Version 2 service Postgres. That's the correct version. Okay, I'm going to download it because I seriously don't see where you're going to run. So here it is. I'm gonna open this here on Xcode. No, Visual Studio. Okay, it turns out in the sample I was giving it a different service name. That's what's going on wrong. I added a few extra models that were specified on the documentation for Drupal. You can see it once again here. Because, well, Drupal stores different things in different directories. So it's telling us that we can specify modules, profiles, sites, and themes. So if we run this Docker Compose file in Docker Playground, I'm gonna stop first my current running directories. And this is something nice about Docker Compose. We don't have to do cleanup for ourselves. If we tell it, okay, we're going to bring down our Docker Compose file, it's going to not only stop the containers, but if we say, okay, we're going to kill our Docker Compose, it's actually going to well, this is nervous typing. I can't seem to type right. It's going to stop everything and it's going to remove the containers for us. So we're going to tell it, okay, we're going to edit the Docker file this time. Yes, I still remember how to use Vim. There probably has to be a better way. I'm going to insert here. Copy this. I'm going to run it. Docker compose up in detach mode so that we can free our shell. And we're going to reload this. There it goes. I'm going to try it once again. And I'm going to actually read the Docker compose file because apparently I forgot the actual password I gave it. The default is Postgres and Postgres according to the documentation. The password is going to be my secret password. I'm going to make sure to copy it this time. And the host is going to be DB. We can try that again. And this time we have successfully recreated our application using just a Docker compose file, which is, like I told you, a declarative way of creating our application. Docker compose file is a great tool, but Docker tells us in documentation that in fact it is a great tool for development and testing. So is Docker right for production? Docker compose can be used in production, but it's not the best tool for it. Thankfully, Docker has created their own tooling for production. Some limitation that we found in Docker Compose is that it was not high availability. Sometimes we want to create multiple web servers and we want to increase and decrease their amount. We don't have that here in Docker Compose. We don't have health checks. We don't have rolling updates. So apparently Docker Compose is mostly a development and testing tool. How do we take it how do we take it to production? Well, thanks to Docker, we have another tool that is called Docker Swarm. Docker Swarm is not an outside tool. It actually comes already embedded in the Docker binary. This is a container orchestration tool, meaning that it allows the user to manage multiple containers deployed across multiple host machines. Once you create a cluster with multiple machines, your Docker commands will now be carried by all the machines in your cluster. Since we are talking about production here, one of the key benefits associated with Docker Swarm is that it provides a high level of availability. It provides multiple features that were not included in Docker Compose. And how it works? Well, since we're talking about orchestration, it means that we have nodes. We have different nodes that are either managers, we have at least one manager, or several workers. And what the manager does is that it handles the workers' resources and ensure that the cluster operates efficiently. For that, we're going to give you a brief example of how to create a Docker Swarm. And we're going to close with this. We can actually Docker Swarm. It's going to tell us, okay, we need an IP. And you can see that now these systems have been part of the swarm. We're going to check how to connect multiple machines running. So we're going to create 2 new instances. I'm going to tell them, okay, we're the only ones working right now. If we want to add one of them as a worker, we can copy this token. And now this has joined us as a node on our swarm. If we do the same thing here as well. And since we're talking now in the swarm, we're going to do a quick example to finish up. And it's going to be, okay, we're going to create a service. Right now, we're no longer talking about containers, but services. And the reason, because we can actually expect them to be multiple of them. Sometimes we want more than one web server. So we're going to say, okay, I want 3 replicas. Going to tell them from mgnuts. And we now know that our service is running. Oh, he gave it its own name. What if we want to change the version of our service? Well, we can update it. We can say, now I want 4 replicas. I want it to be a different image. Let's say ImageNets. I forgot the available ones. We're gonna pick version 1.18. Why? Just because. I'm gonna say update our Hungry Minsky. This is the beauty of Docker Swarm. The containers are being orchestrated inside our Swarm. We're not talking about rolling out this. We're going ahead with high availability, and that's how we take Docker into production. And there are many topics that we can cover that we can still cover with Docker, but we're gonna leave it at that. Thank you.